Hello and welcome to another video in this series. In this video, we are going to learn how to use an interface temperature and humidity sensor. So the sensor that we are going to use is DHT11. This sensor is used to measure both temperature and humidity. DHT11 digital temperature and humidity sensor is a composite sensor which contains a temperature sensing equipment and a humidity sensing equipment inside it, along with a microcontroller that processes the data to give us the final result. It provides a calibrated digital output for the temperature and humidity. It contains a resistive sense for the humidity sensor and a NTC temperature uh, measurement device to measure temperature. So some of the projects that it can be used for are dehumidifiers, data loggers, weather stations, automatic control systems. So this is what DST sensor package looks like. It has 4 pin. Pin number 1 is for VCC. Pin number 2 is data. Pin number 3 is no connect, and pin number 4 is ground. So this is what a sensor looks like for us, which has got 3 pin. The first pin, number 1, is a ground pin. Pin number 2 is a VCC pin, which can be connected to 3.3 volts or 5 volts in our Arduino. And pin number 3 is actually the output pin from where this particular sensor will provide the data for humidity and the temperature. Now, let's look at the feature of DST sensor. It is a low-cost sensor. Um, it can operate from 3 volts to 5 volt power. So the maximum current that it used during the conversion is 2.5 milliampere, which is very low. And it is good for 20 to 80% of humidity reading with plus minus 5% of accuracy. And for temperature, it is good for 0 to 50 degrees Celsius reading with an accuracy of plus minus 2 degrees Celsius. And the measurement can be done every second. Now, before we move forward to write a code to use this sensor, we need to understand a little bit about a header file. So header file in a programming language in C is a file with an extension .h. So this file contains all the necessary function that will be used in the code. And this is a way of making your code reusable. It is written by hash include and then a less than sign and then a file name. For example, maybe temperature sensor.h or distance sensor.h, and then the greater than symbol, or hash include, and inside a quotation mark you can write temperature sensor.h or distance sensor.h. So file.h is the name of the header file. To use DHT11 sensor, we will use a header file hash include simple dht.h, right? Now, before using this header file, simple dht.h, we should install this file or make this file available to our Arduino IDE. Now, let's see how can we install a header file in an Arduino IDE. So to install the library, first you need to open up the Arduino IDE, and then you can click Tools, Manage Libraries. So once you get the library manager, you can search here the name of the header file, simple DHT. So once you search it, you will get a simple DHT file and then a button called install. Then you can just click install and wait for it to download and install the library. You can see the progress bar down here. So once it is done, it says installed here, and that's all. So you can close this window. So this is how you install library for Arduino. And this process is not just for simple dht.h, but to install any libraries in the Arduino. So maybe later on in future, you might come up with some XYZ sensor, and then you need to have a XYZ library. So you can simply go to Tool, Manage Libraries, and then search for the file or search for the header file that you want to install here. Let's see the code to interface DHT11 sensor. So this line is needed because we are using the components in this file, simple dht.h, to run our sensor. So this is a connection. VCC is connected to 5 or 3, ground is connected to ground, and the data of the sensor is connected to digital pin 2 in our Arduino. So DHT11 is declared here to use the components of this header file, which we will use somewhere down in the loop function, right? Inside the setup function, set up a serial monitor so that we can send the information of temperature and humidity back to the computer. So in the loop function, the very first line that is done is sending a bunch of dashes just to mark this is the beginning of the reading. And then there is a text sending from the Arduino to the computer saying reading DHT11. Right here, there is a variable called temperature, which is initialized as a type byte. And this is here just to hold the temperature information, right? So once the sensor sends the temperature to the Arduino will store that value in the variable temperature. Similarly, humidity here is to hold the humidity information. So data is an array to hold 40 elements of byte type, and this will hold the unprocessed raw bits from the sensor. So in order to understand better like how the array works, you can go back and refer to the reading assignments of Programming Basics 1. So this line here is to check if the DHT11 sensor is connected properly, and also this line makes sure that the this temperature variable is storing the temperature obtained from the DHT11 and humidity is storing the humidity, and this data array is holding the unprocessed bit or the raw bits from the DHT11 sensor. So in short, this line actually checks if the DHT sensor is connected properly, and if it is connected properly, it will actually get the information of the temperature, humidity, and the data and store it into these three variables. But if the sensor is not connected properly, if there is an error in reading the data from the sensor, then it will send the information saying reading DHT11 failed to the computer. And then this line here, return, will actually move the program back to the first line here, back to the serial print and dashes, because there is no point in moving forward from this line, because the reading had just failed, right? Now, if the reading is successful and if we have the data of temperature, humidity, and the raw data in these three variables, then we can simply move forward. So this line is just saying that unprocessed data bits are going to be the next that we are going to send from the Arduino. And then here is a for loop that is actually going to loop for all the 40 elements that are stored in this array, data array, and then send all of them back to the computer and simply print an empty space, which is basically an enter. Then this line actually says reading is done, and then these two lines simply sends the information of the temperature and the humidity back to the computer, and then wait for 1 second before we again go back and start reading the second round of data. Right now, let's send this data to the Arduino, and then let's see the reading. This is how the system is set up here. So this is a temperature and humidity sensor which is connected to the Arduino. Yellow wire here is connected to digital pin 2, and this white and the red wire are ground and the 5 volts connected to the Arduino board. Now let's see the information that is sent from the Arduino. Let's look at the serial monitor. So if you look at the serial monitor, let's clear this. The very first thing that is printed here is dash, right? A bunch of dashes. And then let's stop the auto scroll. So the very first thing that is sent here is dashes, and then saying reading DHT11. And then we have raw bits, right? So this line is saying raw bits. And then we have a bunch of raw data. So this data, zeros and one, are data that are obtained from the DHT sensor, right? Now, this data contains the information of the temperature and the humidity, which is also available for us. So we don't need to worry about what this data is. So this line here is just a enter, so that after this line we can move to next line here. So that line prints reading done, and then we are printing temperature and the humidity information, right? So if you look, temperature right now is 27 degrees Celsius, and humidity is around 13 percentage or 14 percentage, right? Now let's look at a quick quiz. So write a code to blink the LED connected at pin 13, digital pin 13, if the temperature is greater than 83 degrees Fahrenheit. And we can assume that blinking an LED is similar to turning on the fan. In your actual project, you can connect a fan. So this is basically a scenario like whenever your temperature is greater than 83 degrees Fahrenheit, then you can automatically turn the fan on, right? So let's pause the video here and write the code. Now let's look at the code. So if you look, the difference between the previous code and the current code is this line here, right? Pin mode 13 comma output. So this is a line so that we can have our fan or LED connected to the Arduino, right? So pin 13 is where our LED is connected. So this is set up as an output pin. So if you look at this line here, there is a new variable called temp underscore f, which is of type float, right? So now this variable is declared to hold the temperature in Fahrenheit. Now this sensor will provide the value in Celsius degrees, right? So we can convert the Celsius degrees into Fahrenheit degrees in our program. So this temp underscore f will eventually hold the value in Fahrenheit that will be converted from the temperature which is obtained from this sensor from Celsius degrees. So if you look at the remaining portion of the code, we are reading the value of the temperature in Celsius and then multiplied by 9 divided by 5 plus 32. So this is actually the formula to convert the temperature in Celsius degrees to Fahrenheit degrees. And then just a line is added here to send the information to the computer, right? So this portion of the code is exactly same as we did for our distance sensor, right? If our distance was less than 5 inch, then we should blink an LED. So in our case here, if the temperature is greater than 83 degrees Fahrenheit, then we blink an LED. So every portion of the code is same here. So in this case, if the temperature is greater than 83 degrees, then we blink the LED, else we turn off the LED. And then we wait for 1 second and start the second round of the operation. So let's take a look at a demo for this quiz. So in this setup here, the output of the temperature sensor is connected to pin number 2. And this LED here, marked with a letter L, is internally connected to pin number 13. So we don't need to connect any wires. Now, let's see the code. Now this is the code for this quiz. So let's send this code to the Arduino. It is compiling, sketch, uploading, and done uploading. Now let's look at the serial monitor here, right? So we have 26 degrees Celsius, and we also have a temperature in Fahrenheit, which is 78.8 degrees Fahrenheit. So this value, 78.8, is less than 83 degrees, which means based on this code, our LED should not blink, right? Because it is less than 83 degrees. So we can also see that LED is not blinking, right? So this LED is not blinking. By the way, the other LED here, the one that is blinking, is a TX LED. So whenever you have a transmission going on from your Arduino to the computer, if your Arduino is sending something to the computer, then your TX LED will blink. And if your computer is sending something to your Arduino, then RX will blink. So let me turn on the hot air to the sensor directly and see the change in the sensor reading. Now, after the exposure of the DST sensor to the hot air, you can see the temperature has increased to 38 degrees Celsius, 100 degrees Fahrenheit, and you can see the LED here is blinking, meaning that our temperature is greater than 83 degrees Celsius, and this code is working perfectly fine. Thank you for watching this video. I hope you enjoyed this video, and I will see you in next video.